Good morning. Good morning, everyone. Today we are going to start with our session with programming in introduction to R programming. So basically, R is a high-level programming language, and it is the one which provides us with the various types of interfaces to the programmer. Now, R basically is a programming language. It's absolutely free of cost, and it can be downloaded from any specific uh, online platform. So it's absolutely graphic open source platform, and it is widely used statistical package which is used by the data analyst and researcher for developing various other platform independent tools. So basically, it compiles and run on variety of Unix platform, Windows or Linux and Mac. Basically, R is a high-level programming language, and provides a software environment for computing, and it also supports graphics. Basically, there are various libraries such as ggplot, which is supported by R programming. So basically, R programming language was created by Ross Ihaka and Robert Gentleman at the University of Auckland and in New Zealand. So currently, R is well developed by R development core team. So as we know, the R is an open source programming language, and new applications and libraries and tools are added to R programming. So to make it much more widely used by the group of programmers and statisticians. The application of R programming language mainly includes three very important domains. First is the R programming language is used for statistical computing. As we see in a lot of statistical packages, the R is one of the leading statistical software which is being used. R is also used for machine learning. So when we use the machine learning tools, so R can be used for various machine learning developing various machine learning model for supervised and unsupervised machine learning. For example, we can use R for regression, for R we can be used for decision support, random forest, and various machine learning model that can be created from R programming. And R can also extensively used in data science. So data science application, which are mostly statistical based, is dependent on R. R can be freely downloaded, and it can be installed from any website, which is absolutely open source. And R is a cross-platform, interoperable, and fully portable software. That means when you write a program in R, it can be carried out from one particular platform to another. So these are the some of the characteristics features of R programming language that makes it absolutely unique and very much useful to the target users. Now, R basically is the one of the statistical is used for statistical analysis, and the companies that have been using R are Facebook for behavioral analysis related to the status updates and profile picture. So R is used by Facebook, R is used by Google for advertising effectiveness and economic forecasting. R is used by Twitter for data visualization and semantic clustering. R is used by Microsoft, which acquired a revolutionary R company, and it is used for a variety of purposes. R is used by Uber for statistical analysis. R is used for Airbnb that can scale the data science driven application. So these are some of the top tier companies that are using R programming all over the world for statistical analysis. And these are some of the top tier companies that we can see which are using R programming. Now, what is the features of R program? And basically, R is developed by John at Jane Chambers at AT&T Bell Laboratory. So it means that R is an implementation of S programming language with lexical scoping and semantics. So basically, it's inspired by S language, which was developed by John Chambers in the year 1976 at Bell Laboratories. And the commercial version of S was offered as S Plus, which started in 1988. And are basically the one which is being designed and developed on the basis of this S Plus. Now, when we come to the R programming language, there are certain features of R programming language that makes it absolutely useful. Number one, R is very simple, it's very effective, and it's well-developed programming language. And it includes conditional looping, user-defined function, recursive function, and input-output facility. So these are the certain features of R which makes it very, very useful. The second feature is that R provides a large, coherent, and integrated tools for data analysis. So basically, the R programming has a large repository and integrated collection of tools that we use for data and analysis. R has an effective data handling and storage facility. So we can handle the data effectively and we can store and retrieve the data as per the R programming languages used. R provides various operator that for calculation on array, list, vector, and matrices. So these are some of the features of R programming that makes it very, very useful. R provides graphical facilities for data analysis and display directly to the computer or by printing paper. So this is some of the very, very important application of R programming language. Now, what are the various uses or features of R that makes it very, very useful in data science domain or in any particular programming domain? First one that is very important is fast calculation. R can be used to perform complex mathematical and statistical calculation on data objects on a wide variety. So this is one of the very important function of R. Number two is R is extremely compatible. It's an interpreted language, mean that it does not need a compiler to make a program from a source code. So it is makes the R compiler to code very effectively. R is open source software environment. You can improve and you can add packages for additional functionality in R. So it's absolutely an open source platform. R provides cross-platform support. So R is machine independent and it supports cross-platform operations. So there can be many different type of operations which is supported by R. R is used for wide packages, that is more than 10,000 different packages and extension that helps to solve all sort of programs in data science in R. R support large standard libraries. So basically R can produce statics graphics with production quality visualization, and it has also have different type of extended libraries, and it has to provide, it can provide interactive graphics capability. So these are some of the features of R programming that makes it very unique and very useful for data science and for developing any statistical based application. Now we come down to the syntax and semantics that we use in R. Every programming language has got some syntax and semantics. So our programming language also has got certain syntax and semantic that makes it very, very useful to the programmer. We can use the input-output statement. So R has some very basic syntax and semantics that we use in programming. For example, smaller case and uppercase has got different interpretation. The syntax that we use in R will has certain data types. R support variable, R support operator, keywords, and data structures. So these are the some of the syntax and semantics which are supported by R programming language. So R has got data type, it has got variable, it has got keywords, operator, and data structure, which is widely supported by R programming language. So R can be used for a reference data frame and for a column, right? Now, these are the basically six data types that we widely use in R programming language. Number one is the integer data type. It takes integer values. Second one is the numeric data type. Third one is the logical data type. Fourth one is the raw byte data type, complex and character. As we know, the integer and numeric data type we have been using logical and or not. Raw bytes of data, which is provided by raw data type, and complex can support complex type of data, that is the complex number, and the character data can support single character or it can support string. So these are the data types which are widely supported by R programming language. Now, what are the variables that we use in R and what are the rules and semantics that we use in R programming for naming a variable? So a variable is a name that is a combination of letter, digits, and dot and underscore character. And it has to start with a letter. So if it starts with a dot, then it should be followed by a number. So reserved word in R cannot be used in a variable. For example, the keywords or the words that are already defined, predefined, cannot be used as a variable. So these are some of the rules that we need to follow while defining and declaring a variable in R programming. Now, what are keywords? Keywords in R programming language are those words that are predefined words, and these words have some special meaning, and it cannot be used as a name of identifier. So, the words that are having a predefined meaning and which has got some special meaning and that cannot be changed can be used as an identifier. So, identifier are the one which is user defined. Keywords are words which has got predefined meaning. For example, if is a keyword, else is a keyword, a while is a keyword, function is a keyword, for is a keyword, in is a keyword, next, break, true, false. These are all example of keywords. The keywords are those words that has got predefined meaning, and identifier are something which are user defined. For example, a name of a variable. For example, a name of a function that is given by a user. All these are example of an identifier. So there is a difference between an identifier and a keyword that we use in our programming language. Now there comes an operators. So operators in any programming language are the symbol which performs some sort of operation on an operand. So R has several operator that performs arithmetic, logical, and bitwise operation on the operand. So the most common operators that we use in case of R programming language is an arithmetic operator. So arithmetic operator, for example, addition, multiplication, division, modulo division. These are all example of arithmetic operator. Number two, we have the logical operators. A logical operator in R programming, we have AND operator, OR operator, and NOT operator. We also have the relational operator such as less than, greater than, less than equal to, and greater than equal to, and not equal to. R also support assignment operator, which can be used in different form, and these are the certain symbol of an assignment operator that we use in R. The difference between the assignment and the equal to operator is that the equality on both the left hand side and right hand side is seen when we use the relational operator double equal to. But when we use the assignment operator, whatever is the value of the variable in the right hand side is of the expression is assigned to the left hand side. So this is are the some functions that we use in R. R supports two type of function. One is a built-in function. The second one is a user-defined function. So the built-in function is something that is already there, and we are using that particular function to use that function in our program. For example, there is some function already there, with suppose power square root function, sqrt function, which are example of a built-in function. User-defined function, the one that we create and that we use in our program for our coding purposes, that is called as a user-defined function. So R support built-in function as well as an user-defined functions also. Now, what are the built-in functions that are provided in R? So the built-in functions that are provided in R basically is a sequence function. So if you write sequence 5, comma 15, you'll get the values 5, 6, 7, and so on. Whereas the sum function that you can see over here is a user-defined function. Because the sum function is defined by the user, so the function that is defined by the user is a user-defined function. The function that is already there and it is used in a program is called as a built-in function. So sequence is a built-in function, and sum here we see is a example of a user-defined function. So user-defined function in R programming is different from a built-in function that we use. Then we have the user-defined functions. How do we define a function? What are the arguments that we provide to the function? Is the function returning a value to the calling portion of the program? That plays a very important and vital role. So here we can see a function with argument, a function without argument. A function that is defined is taking an argument to value a and b, and the function that does not take any argument. So we can have two different cases of a user defined function, one taking an argument and the other one is not taking an argument. Then we have conditional statement in R. The conditional statement is if-else statement, Swiss statement, nested if-else statement. So these are all conditional statement in R programming, and these are used to make decision based on certain conditions. So conditional statement in R that we are using, providing some decision, and based on this decision, the conditions are being evaluated. So first one is if-else statement. So in if-else statement, we check for a condition. If the condition is true, the true block of the program is executed. If the condition is false, the false block is executed. So if-else statement is a conditional statement which can either execute the true block or the false block based on the condition that is provided. So R supports conditional statement or if-else statement which is being executed depending on the condition that we evaluate. Now, switch statement is another statement that we use in R programming. So when we use a switch statement, it will switch to that particular case expression that is being provided. So we pass two argument. One is the value and the other is the list of item. The expression is evaluated based on the value and the corresponding item it returns. So if the value is 3, it will return that particular item from the list. If the value is 2, it will return that particular item from the list. So this is a switch statement that we use in R programming. Then comes iteration or looping. Looping is a very important part in R. Loops are used when we need to execute a particular code. Suppose if you want to execute a particular code, there are two types of loops that we use. One is the for loop, the other one is the while loop. The for loop where we iterate and we provide the loop control variable and the condition. And in the while loop, we provide the condition and then comes the body of the loop and the loop counter variable is incremented by 1. Now, this is an example of a looping construct that we use and if else condition that we have used. So we check for a condition. If the condition is met, if it is not met, then the counter will be incremented by 1 and it'll print the count by 1. So basically we count the number is even number in a vector. So basically to count a number is even vector, we try to iterate one by one the different element in that vector. And if it encounters a even element, the counter is incremented to 1 and then it displays the count. This is a while loop where the while condition is checked, and here in the body of the loop, we are printing the value I as 1 and the value of I is incremented by 1. So our programming while loops are used to loop until a specific set condition is met. So once the condition is met, the iteration will stop. Then we have a repeat loop. A repeat loop is used to iterate over a block of code multiple number of times. So if you want to iterate over a block of a code multiple number of times, then we use repeat loop. And there is no condition check in the repeat loop to exit the loop. So this is what we do for repetition of a loop or for iteration. Then we have different data structures that we use in our programming language. And the data structure is very, very important and it plays a very specific part in our programming. So the idea is to reduce the space and the time complexity of performing a different task. And for that, R provides different data structures like vector, matrices, list, data frame, factor. Now we look into the other aspect of this. Now, vector plays a very important role. One of the basic data structure in R, it supports vector, which can be of integer type, it can be of character type, it can be of logical type, or it can be of raw data type. So elements in a vector are known as a component of that vectors, and vectors can be you created using these two different methods. We can use a sequence by virtue of which we can create a vector. So vector will display the number in a given order or a sequence, one after another. This is a few examples of vectors that we use in our programming. So where we can combine one or more than one vector. We can perform arithmetic operation on this vector. We can use the numeric indexing on the vector. We can provide logical indexing on the vector. We can use the range indexing on the vector, or we can use the duplicate indexing in the vector. So these are the various operations that we can perform in a vector, right? And then we have array. So array is also a very important part, basically, to store data in a multi-dimensional or a single dimensional way in a very efficient way. So this is how we access the array element, and we perform in other programming languages like C, C++, or Java. So array plays a very important role to store data in multi-dimensional and in a very, very efficient way. Then we have a data frame. So we can create a data frame, which is one of the very important data structure in R. And the column name should not be empty. A row name should be unique. And data is stored in a data frame only in a numeric format or factor or character. And each column should contain the number of data types or that we are defining or declaring in a data frame. So product is a data frame which has got a product number that is in a sequence from 1 to 4, and a product, four different or distinct product names. So with product number 1, you have got a product name. First, the second product number will have the second product name. The third product number will have the third product name. And the fourth one will have the fourth product name, and so on. Then we have list. So list also playing a very important and vital role in our programming. So list is basically a data structure that have component of mixed data type. So a vector having element of different data type is called as a list. So list can be created using a list function where we store the different data types, and we can access the list element one after another. And we can manipulate the element in a list, and the list can be created using a list function that we use like this in our program. Then we have matrix. Matrices are the two-dimensional rectangular data set that is called as a matrix. Matrix is created with the help of the input vector, and we can perform different operation on a matrix such as addition, subtraction, multiplication, division on a matrix. So we can create a matrix of different rows and columns, and then we can populate the element in those matrix, and we can perform different operations on those matrix. So these are the matrix operations which can be performed in R, and this is how it can support matrix addition, matrix subtraction, matrix multiplication, and transpose. Then R also supports factors. Factor are the object data which are used to categorize the data, and it store it as a various level. So a data field such as Marshall status that can only contain one value is an example of a factor. So basically the repetitive data in the are not displayed again and again. Factor has four element and two level, and we can check if a variable is a factor or not using a class function. So if a variable is a factor, then the class function will return it as a factor. Then we use the RStudio. So RStudio is a free and open source integrated development environment for R programming. It is used for statistical computing and for graphics. So RStudio was created and founded by J.J. Elliott. He is the creator of programming language such as Cold Fusion. And there are four main sections that we see in RStudio. It's a part of integrated development environment. On one side, we'll be having the code editor. The other side will have the workspace and the history. Then we'll be having the R console, followed by the plots and files that we have defined. So the RStudio is available in different edition. One is the RStudio desktop, and the second one is the RStudio server, which is the prepackaged distribution, and basically it's used for programming framework. So why to learn R programming? There are various reasons why we need to learn R programming. First, it supports free and open source tools, so which is very, very important because it's absolutely free of cost. It's a general user license, so anyone can go and download the R software. It supports the large community of user. It has used latest cutting technology. So R software is using the latest cutting technology. It has independent platform. It has independent platform. So whether you're using MacBook or using Linux or using Windows, you can use R programming to configure your device or your configure your program. I can write a program with any type of configuration. So it's platform independent. It's a gateway to lucrative career because the R programmer are in very much demand in the market. It has a robust visualization library. So basically ggplot and other libraries which supports enhanced visualization in R, and it is extensively used for statistical packages. Basically, you can do multivariate, bivariate, and univariate analysis using R programming. We can design or we can do correlation, regression, and we can do descriptive statistics, inferential statistics, and probability using the R with the time series data. So it is used in almost in every industry. So most of the industry that are, nowadays are using R programming extensively. So that's about the basic about R programming. How these are some of the features. These are some of the special features in R programming. For example, it is used for graphical techniques, linear and non-linear modeling, time series analysis, which can be performed with R programming, machine learning algorithm for classification and clustering can be executed in our programming platform. Parametric and non-parametric tests can be performed in R programming. R programming support linear and non-linear modeling of data. So these are the features of R. We already have seen the vector, the matrix, the array, the data frame, and the list that we use in R. So these are the data structure which is supported in R programming, which can be accessed properly. The most comprehensive statistical analysis package which is available with outstanding graphical capabilities, basically the R, and it supports GNU. The GNU is the general user license which is supported by R, and R is absolutely platform independent. Basically, it can be used in Linux, Mac, and Windows platform. Now, how to install R? We've seen how we can open it's an open source. It can be easily installed on your device. And very important part in R is after the installation is done, we can use the R Studio and we can configure the R Studio. And this is how our R Studio can look like. And these are the archive that we can store or we can refer into. So this is how the R Studio can be used with our devices, and that can be easily configured. Now, R supports different type of data or data structure. So how do we define a data in R programming? How we use that data? What is a vector? How do we define a vector? How do we define a list of element in a vector in a R Studio? So this can be properly identified in this matter. So we can provide a histogram or we can provide a QQ plot or PP plot in our programming, and it can give us some normality or plots or histogram as per our requirement. We can use factors or metrics in R. The factors will provide the element from the vector, and we can also get the dimension of a matrix that we are using, which is multidimensional, a combination of row and column. So we can see the summary or we can see the dimension of a matrix. And then we have the data frame starting with R. So data frame that we can use in R, we can have some built-in data frame. that the R Studio supports. And we can get the summary data from the data frame. We can get the correlation or paired data, and that can be displayed one after another. So this is how the data frame and their plots, that pair plot, we can get it from R, or we can get the correlation between two different data set. Now here, the regression model, we can also do a regression model with R. The function is lm. And the regression model, we take one dependent variable and one independent variable. And based on the dependent and the independent variable, we perform the linear regression. And the linear regression will provide us with the summary model, where we can get the value of R square, where we can find out whether the independent variable has got any significant impact on the dependent variable, and we can create a regression model in the R. So this is how the regression model output it looks in an RStudio, and this is how the residual standard value will be having the mean, the interquartile range, the median, and the other significant factor, the standard error, the t value and p value, which can be identified in the linear regression model. It can also show us with the value of R and R square respectively. And this is what is the LM or the linear regression model looks like. These are the basic diagnostic plots which can be generated in RStudio using normal QQ club plot or residual plot or other different types of plot with linear regression that we use. So this is how we use the linear regression, correlation, or descriptive statistics or inferential statistics in R. And these are the various confidence limit on the estimated coefficients that can be properly calculated and identified in case of R programming language. R is extensively used for visualization that we use. Suppose we can plot a box plot or linear line chart or other visualization using the RStudio. Or we can identify an outlier in a data. R provides probability density function, that is PDF, which is used for histogram, line densities, and other. And these are some of the regression trees which can be generated, or a hierarchical tree, and a particular plot which can be generated using R. And this is how your regression tree looks like in case of RStudio. So which is a hierarchical structure. And you can see how the hierarchical structure looks like. And it can predict logs of clicks that we use. So these are some of the resources that you can use for R. And this is how the RStudio is extensively used for